Well, welcome back to the Azure Podcast. This is episode number 489, being recorded on the 6th of March, 2024, with special guest Ben Hummerstone. I'm Sajid, and on Teams with me we have Ben, of course, to discuss a very special topic, which we'll get to in just a minute. But before that, let me just cover a few updates that happened this past week in the Azure space. A few actually, many of them around AKS, but there are a few that are not directly related to AKS. Let me cover those first. The one of them is Azure NetApps file volumes. There's an enhancement now which allows you to mount the same volume from different availability zones, right? So it used to be that if you wanted to have DR, you'd have to create another volume on the second AZ so that and then kind of replicate them. Now you can have the same volume on both AZs so that in case you're doing a failover, you don't have to do all sorts of reconfiguration of your app, and all the app just continues to work because it's pointing to the same volume name in the other AZ, and so it makes that whole replication and failover a lot easier. So that's something if you're using Azure NetApps files to watch out for. And then, kind of a quick reminder, this has been something that we've been talking about for a while, which is the Cloud Services Classic. I don't know, Ben, if you've been involved with Azure since day one, but you might remember Cloud Services. And they were like the very first services that Azure had. And in fact, I spent a lot of time working on them with a big insurance company here in the United States. And so happy to know that they have moved off cloud services. And if you're still on it, you should be. You have to. You kind of have to move off it because that is getting retired on the 31st of August this year. So not a whole lot of time to do that. So that's something that's coming up. And then, as I said earlier, we've got a few AKS updates. One is Kubernetes 1.29, which is kind of the more current supported version, is now available in AKS. So you can kind of upgrade to that version or deploy to that version if you already have AKS. Let's see. One of the problems with the AKS nodes, right? If you use Linux nodes, you had a choice of Ubuntu images or Azure Linux images. And if you decided, hey, I want to switch from Ubuntu to Azure Linux or Azure Linux to Ubuntu, it was quite a drama, right? Because you had to kind of spin up a whole set of new nodes with the new image, and then you run out of your quota for nodes in your subscription because you've got like all these large number of node pools and whatnot, and it could result in some sort of drama for you. So they made that easier now, where they do the in-place upgrade of the image in the node itself, right? So you basically just take and the node is directly updated. The OS can be updated from one version of Linux to another without having to do that, expansion of your node pool. So that's something to look forward to if you ever do that kind of migration. Also in AKS land is Istio-based the mesh services, right? So if you use a mesh-based system in your application, you want to take advantage of that. You have the option now that's officially kind of supported as an add-on in AKS. And then, if you use network policies, things like the Azure CNI or any other of the commercial network policy engines in AKS, if you want to migrate from one policy engine to another, it used to be a bit of a headache because the policy itself would get in the way of doing the migration. And so now there's an option where you can disable network policy temporarily, do the migration, and then kind of re-enable it, right? So just to make things a little bit easier during that migration from one to the other. And there was one more non-AKS related update I wanted to share, and this is somewhat directly related to OpenAI, right? With the advent of OpenAI, as you know, we are doing a lot of applications that are streaming, right? This has become a new paradigm where you can ask a question and then the kind of answer is generated over time, right? They call it Gen AI, and the response is streamed back to the browser a little bit of time. You may have noticed that, when you ask a question, kind of the answer kind of just keeps on streaming onto the screen. And for that, it requires HTTP streaming protocol to do that, right? So you can kind of stream that response back. And now Azure Functions supports the HTTP streams if you use Node.js as your language in Azure Functions. So that update is now available. It's in public preview. Right. So those were all the updates that I had. I picked a few of them that were kind of seemed interesting. There are a lot more, but we'll put links to them in the show notes. But now's time to hand the mic over to Ben. Ben, thanks so much for joining us today. Please go ahead and introduce yourself to our listeners. Tell us, what you do in Microsoft and what your passion is in the Azure space, and then we'll take it from there.
Thank you very much. Lovely to be here. So hi, everyone. My name is Ben Hummerstone. I am a cloud solution architect at Microsoft. Been at Microsoft about 8.5 years now, I think. Started in the field and then went over to the engineering side for about 5 or 6 years. And as of about a month ago, I'm back on the field again. So needed to go back to my roots from when I first joined the company. In terms of sort of technical specialisms, I'm more of a specific generalist. Let's put it that way. In that I'm interested
Hmm.
in pretty much everything when it comes down to it. So whether it's traditional infrastructure, so networking or storage, as we're going to be talking about more today, through to lots of stuff with containerizations, and even some more of the data side, like Cosmos DB. And I understand some of the maths behind machine learning, but I haven't necessarily done the practical side. But yeah, interested in pretty much everything when it comes from a cloud perspective.
Yeah, and I can see how that's important if you take a field role, right? You obviously go to a customer, they kind of expect you to know kind of a little bit about everything, right?
Yeah.
Like you can't just go in and say, oh, I don't know that, I don't know that. You kind of have to know the lay of the land. But of course, you have some areas of depth in your expertise, which is always good to have. Yeah, so one of the areas that I had reached out to you for is around Azure Storage, right?
Mhm.
It's kind of a topic that we haven't covered over here in a very long time, and specifically Azure Storage, right? Obviously, we mention it in passing as if it's just there, but there's a lot of I've been doing a lot of Azure Storage as long as not as much as you have, but it's something like it was 2 weeks ago when we did a podcast on Azure Key Vault, right? And I made the comment that there are a few fundamental services in Azure, right? There's the
Mm.
VNets, there's the virtual machines, and then there's the storage, right? And then I went on to say in that particular instance that Key Vault I considered also to be a kind of a fundamental part you have to have, right? So those are kind of the basic building blocks of any Azure deployment that you may have, whether you use it directly or indirectly, it's there for you. Uh, but I get the feeling that, people may not be, or customers may not be leveraging or using or configuring or thinking about storage in the right way, right? It's something like you tick a box and you get storage, but there's a lot more that goes into it, is what I've come to understand. And that's what I wanted to kind of pick your brain on today, Ben, is just, what are some of the things that Azure, what you seeing in the way customers are using storage? What are some of the common pitfalls, mistakes that they make? And then we can talk about some more kind of advanced topics like redundancy, resiliency, yeah, kind of application-focused topics as well, if you don't mind.
No, it sounds great. Yeah, it's one of those interesting things, really. Like you said, it is such a fundamental that it fades into the background. It's just taken for granted that, oh yeah, storage is there. And it's amazing how
Until
the
it's not
same,
there.
exactly, yes, but it's amazing how the same kind of underlying platform can be surfaced in so many different ways. So the the kind of the first iterations of the storage architecture it's the same underlying platform that serves, it's even now, table storage, storage queues, disks, files, blob, ADLS Gen 2, all of this kind of stuff is built on the same fundamental infrastructure and fundamental architectures underneath. And then you have all these different insights into them, all different lenses, looking at the same kind of massive distributed platform under the hood. And yes, it's very, very rare that someone comes to us and says, I want one storage, please. It's always the case of, I have this application, it's running in Kubernetes or something like that, but I need some persistent storage to have active between pods. And you can say, okay, we can do that from blob storage using NFS. And someone else comes along, I've got some VMs, they need disks or whatever it's going to be. So it's amazing the versatility. that it can come up with, and that's supported on such a massive
Yeah.
distributed platform.
One of the first questions that come to mind. This is something that's always troubled me when I am prompted in the portal to create a storage account. Right. This, so storage account, like you generally tend to create one way is to create a storage account for every use case that you have, right? Everything you create. So you wind up with like, a gazillion storage accounts, right? Which, as
Yep.
you know, is a management nightmare. And so the first question I have, like, when users set up a storage account, when should they be thinking of setting a new storage account versus say, hey, I already have one in the subscription or in the resource group, right? And I'll just reuse that. I've often done that, right? Oh yeah, there's this storage account line. Yeah, I just need some blob storage. I'll just use it, right?
Mm.
So I'd like to kind of start with that. Like, what's your recommendation on just the way accounts are set up, storage accounts are set up?
Yeah, and that's actually something that's changed over the years. Because it used to be, again, going back to even just a few years ago, there were some quite strict limits on what a single storage account could provide in terms of even sort of things like resource-based access control and things like that, or through to a certain amount of IOPS and bandwidth and things like that, and space that was only available on the storage account itself. And there's been a lot of work from the storage account teams to remove those limits in a lot of circumstances. So now you can store hundreds of petabytes in the same storage account. You can get a terabit's worth of throughput on one storage account. So some of those use cases where you think, I'll just spin up another one, I'll just spin up another one, they're not really relevant in the same way anymore.
Mm.
But as we were saying earlier, a lot of storage accounts are created behind the scenes by other applications and things like that. So in some ways, there's some work required within Microsoft to say to those teams, by the way, you don't need to keep creating storage accounts. You can
That's right.
share them between instances of your applications. It's always an interesting one to see. Like with Azure, something like storage and networking and other fundamentals, a lot of Azure is built on Azure. So you end up with these interdependencies between
Mm-hmm.
applications and other platforms of service things relying on other applications and fundamentals like storage. So yeah, if you're just creating a storage account, you can probably just create a new container in an existing storage account, but understand what any potential limits that might exist. They're very high now, and most of them are kind of soft limits as well.
I see.
But have a think about that on a per kind of application and per use case.
Okay, that's very good. Yeah, and once you kind of get past that hurdle, the next question that I've stripped me up a few times is, whether it's the general tier or the premium tier, right? So that's the kind of other question they ask you, and then of course it goes on to what's the other the availability, right? Of course, that's a big one,
Mm.
right? LRS, GRS, ZRS, and whatnot. So maybe you could just kind of guide us on, what we should be thinking as we go through that portal experience or process to create the account.
Absolutely. So if you're thinking about the kind of the performance tier, let's start with that one. So it's all about, if you're doing it kind of air quotes properly, then you should really understand how your workload is going to use the storage. A lot of this stuff it doesn't have to be perfect the first time around. You can change it as you go along. But it really helps to really understand how your application is going to be using that storage platform. So if you've got lots of small files and you're doing lots of little transactions, but you haven't got a huge amount of data, say you've got 10 million files at 10 kilobytes each or something like that, then something like premium storage might be a very good choice there because you get much lower latency because it's backed by solid state disks kind of entirely. And if you're doing lots of transactions, the kind of cost for transactions for premium is much lower than something like any of the other performance tiers. So if you start thinking, okay, well, lots of files, lots of transactions, not a huge amount of data, let's go with premium storage because that might actually be the most performant and cost efficient option for you.
Hmm.
Then kind of the next kind of hot, as we call it, from the Azure perspective, is kind of a step down, where general purpose, that's going to be good enough in a lot of circumstances. It's a nice balance between the cost of storing the data versus the cost of accessing the data. And there's always this kind of trade-off as you're looking at the different performance tiers. If you go down the chain to something like cold and cool storage and archive storage and things like that, the cost of storing the data goes down, the cost of accessing the data goes up. And so that's when really understanding your workload and how it interacts with the storage platform can really start to make a big difference. And kind of the good thing is that you can actually move individual files around within your storage account as well, using tiering within your storage account. So you could say,
I see.
I've got a container which is hot data, and that's going to be, okay, that's the stuff that's used most frequently. And then after a certain amount of time, that gets tiered down to cold storage or cool storage. So it's accessed more infrequently. Therefore, you can kind of justify paying the higher access costs because there's fewer of them, but it's cheaper to actually store that data. And then tier it all the way down. So I have people that say, I've got this data, I never look at it, but I need to keep it for regulatory requirements or something like that. So something like archive storage, perfect for that use scenario, where it's ridiculously cheap to store it, but the access costs and access time is much higher.
So you just brought up a good reason. That's one good reason to have different accounts now, right? Is when you have to have these different tiers, that's one of the reasons you would create multiple accounts and then move information between the accounts. Is that how you think about it?
Not necessarily, because you can do the tiering within the same account. So even you can actually go down to some very granular levels about how you tier things. So you can tier individual blobs if you want to, even within the same container.
I see.
But so it's you don't have to copy data around. You can just say, I'm just going to move this particular file, this particular blob to a different tier. And we've got platforms in place and sort of tools to do that automatically. So you can say, after last access time is always a good one. For any file that hasn't been accessed in the last 30 days, tier it down to cool storage. And if it's not been accessed in the last 90 days, tier it down to cold storage. And all with this, without having to copy things around, it all works in place. And you can then say, rehydrate it back up the tiers if it becomes hot again.
Oh, so if you do find it accessing it more frequently, then it kind of moves it up. Oh, that's very cool. So that definitely takes a lot of the management overhead out of this. That's great.
Absolutely.
All right, so we've kind of covered, I think one of the two of the most important areas. Now we get on to the redundancy kind of question, right? Which is again something that I don't know. I feel like it's not well explained, right? To be honest with you, it's such an important decision to be made at that point in time. I don't know. I always look at it from a cost perspective. Oh, LRS is the cheapest, right? So I'm going to pick LRS because it's the cheapest. But I know that's not the best idea.
I mean, it's interesting because it might be the best for you in that particular scenario. Again, it's the level of redundancy we have. It's interesting because, like I say, storage is one of those fundamentals. It's one of the first services that was actually available in Azure, and it was used for serving things tens of years ago, really. And it predates availability zones, which is an interesting concept as well. So something like LRS and GRS, the only way to do high availability and DR for storage was to replicate it to a paired region. That was the only way you could do it back in the day. And that obviously has changed over the years. We have availability zones in loads of regions now. Some of our newest Azure regions don't even have a region pair. So GRS isn't necessarily the best way to actually achieve your goals there.
Ben, I just wanted to maybe just also elaborate a little bit on what those acronyms mean, just so that our listeners are familiar with that. So you mentioned LRS, ZRS, and GRS so far.
Absolutely, yeah. So LRS stands for locally redundant storage. And to talk about the kind of some of the nitty-gritty of the storage architecture, when you create a storage account, it's pinned to a particular stamp of storage, which means a deployment of the storage backing storage infrastructure we have within our Azure region. And that stamp is in a particular data center. There's some front ends, there's some other layers of stuff that we have within the storage architecture, and we can share some links about that where we go into this in a lot of detail. But the idea is you create your storage account, it's pinned to a particular stamp, and you can actually do an NS lookup of your storage account or a dig in Linux and see the name of the stamp in the DNS record. But what that means is that that stamp is in a particular data center. So if you choose LRS, your data sits in that data center. So that's locally redundant storage. Something more resilient than that. Resilience goes up, cost goes up. Unfortunately, we're storing more copies of your data. If you choose zone redundant storage, ZRS, ZRS for our American friends, then you get the data is replicated across 3 stamps in separate availability zones. And that's synchronous replication. So you do get an initial write penalty because you are writing your data synchronously across 3 zones, which could be tens of kilometers apart in order to meet kind of high availability requirements. But then you have your data from a redundancy perspective, straight away 3 zones. If there's an outage in one zone, it's already there, ready and waiting in the other 2. The next level of redundancy would be GRS, which is geo-redundant storage. And that is where you write your data locally. So it's LRS, locally redundant once in one stamp, and then it's automatically asynchronously replicated to the paired region in Azure. Again, one of the concepts we have, quite a few of our regions have a paired region, and it is only really nowadays to support geo-redundant storage. It's very much the historical fashion there. It is an asynchronous replication, but what it means is that you have it locally redundant in one region, say UK South, and then asynchronously in the background, Microsoft replicates it to the paired region, in this case, UK West, and it's stored locally redundantly in UK West. You can kind of keep going from there. You can also combine the 2. So you can have GZRS, where you have geo zone redundant storage. We keep adding letters to it.
Oh my God.
But for GZRS, it's kind of zone redundant in the primary region and then automatically replicated locally redundant in your secondary region.
I see. So the chances of switchover are less in that case, right? Because most likely, one of the zones is available in the primary region.
100%, yes. And it's one of those where the kind of availability conversation and resiliency, redundancy conversation has evolved over the years, where for the vast majority of applications, zone redundancy is good enough. And I don't mean that in a derogatory way. It's just you can meet your availability goals as an organization for your applications by running it zone redundant across multiple zones in a single region. Hence why our newest regions don't have a region pair, because you don't necessarily need that geo redundancy from a storage perspective.
Got it. So okay, so that's a good run, and I believe did you talk about RAGZRS yet? There was one more, right?
No, yeah.
Okay,
this is
I remember
next
because
one.
I remember using that, and that was the most complicated one, if I recall.
Yeah. It's interesting you should mention Key Vault, because that uses RAGRS under the hood. So RAGRS is read access geo redundant storage, and that means you have your initial copy in your primary region, and then you have a readable secondary copy in the paired region. So it means that it's quite good for certain cloud patterns where your application's writing a lot in your primary region, but you want to do reporting in a secondary region. So you can just use that read access to your other storage. Or for something like Key Vault, where you've got your keys in your primary region and they're replicated to the secondary region, you can access your keys from that perspective as well. But yeah, that's kind of your main options there.
Excellent. Now, I know you mentioned disk storage being another kind of use case, right, for storage. And you did say that it's also hosted in Azure Storage, but it doesn't really show up in if you just create an Azure Storage, disk does not show up there as a primary thing. So is this like a special storage account that has this storage? How does that work?
Historically, it used to show up in there. So when
Mm,
you first started with Azure, unmanaged disks, if you can remember those back in the
that's
day,
right.
again,
Yes,
you don't
yes.
want to go too far down memory lane, but you used to have to create a storage account to hold your disk objects. And they're actually a special type of blob, a page blob, which is optimized for random access, which is generally speaking what disks are used for.
Mm,
And even now, premium SSDs, standard SSD, all of that kind of thing are still using that same back-end storage infrastructure. It's all the same infrastructure underpinning it. So when you create a premium disk, it gets created as a special type of page blob. There is a storage account created behind the scenes. You just don't see it, and that's used to handle the actual blob writing to and from your virtual machine. Um, that's all well and good, but we see customers have some struggles with that because the massive distributed system from a storage perspective has it's very, very good at parallelism and high bandwidth and things like that. And virtual machines are not.
hmm
Generally speaking, if you're using a virtual machine, you don't really care about high bandwidth unless you've got some specific workloads like SQL or whatever that require it. They like very fast, low latency, random access. And the massively distributed storage architecture wasn't necessarily the best at that. It wasn't designed for that. So we did the best we could with caching and everything like that. But it became clear that in order to meet customers' requirements, we needed to change and think about a different way of dealing with disks.
Mm.
And we first saw this with Ultra disks, which actually uses an entirely different structure from a storage perspective, an entirely separate architecture. And that's how you get sub-millisecond latency and hundreds of thousands of IOPS and multiple gigabytes of bandwidth and things like that. It's designed from the ground up to support virtual machines and disks. And you get this now in, again, I love our naming scheme sometimes, Premium SSD V2 is built on this same infrastructure as Ultra disks. So you get very, very low latency, very much higher performance, configurable bandwidth and IOPS to support your workloads.
And not to complicate the discussion on disk anymore, but how does how do the redundancy options fit when you use disk storage?
Yeah.
Are they, you just assume they're all LRS for the purpose of being able to access them quickly? How does that work?
You can change it. So you can have the default is locally redundant disks. So it's just within one availability zone. And that's to give you the best latency. So if you're writing by default, you want your VMs to be able to write quickly to and from storage and read quickly to and from storage. So the default is LRS. Again, I don't want to go down history too much, but you used to be able to have GRS disks,
Mm,
and that was always a problem because we have asynchronous replication under the hood, and it operates not at a file level, like you're using a VM, you want to write a file. It operates at a kind of a block level behind the scenes. And people would think, oh, yeah, I can just start my VM in another region and it will all be fine. And that's really not the case because you may end up with files, half a file here when it's written
right.
in your primary. So LRS is the default nowadays, and we don't allow GRS as an option because it just never really works. But you can also have zone redundant disks. So you
I
can
see.
actually create a disk object that works across multiple availability zones. And there's some really cool stuff you can do there where you can have a cluster and have the disk as a clustered resource. So you can have reading and writing from active in some fashion to this disk with your clustering software preventing
I
write
see. So the
conflicts.
VMs are could be in different zones, but accessing the same storage, uh,
The same disk object, yes.
same disk object. Yeah,
Yeah. And that
that's
gives you a
interesting.
really kind of advanced level of availability for your workloads. You don't have to copy data around because the storage subsystem handles it for you. You don't have to have SAN replication or something like that to
Right,
have
right.
your data in multiple data centers. You say, Azure, give me a zone redundant disk, please. And there it is.
Wow, that's great. When it comes to zone redundancy or just storage being in different zones, as an application developer, if I have an app running in a VM, I want to make sure that the disk that is connected to is like right next to me, right? You know how it is. In the old days, we'd want to, okay, it's got to be in the same network. The SAN storage has to be like, just one Ethernet port away, right? Uh, but it sounds like we're not able to guarantee that with the fact that, it's we don't know which AZ. This was one of the things I had reached out to you
Mm.
earlier this week, is the VMs in an AZ, but we're not sure which AZ the storage account is, right? And whether that's in the same AZ as the VM, we don't know. But whatever. Azure is guaranteeing us some throughput and latency and performance numbers, but ideally you want it to be in the same AZ. Is that a fair ask, or is that something we shouldn't think about in Azure?
Again, it goes back to your workload. And some workloads will absolutely care about having the lowest latency. Now, from a disk perspective, Azure does guarantee the same availability zone if you deploy your VM into an availability zone. So when you're deploying a virtual machine,
I
you
see.
can
I see.
say deploy into a region, and Azure will just pop it in a region somewhere, and you don't have any choice. And then the disk may or may not be in the same availability zone. If you say I'm creating my VM, put it in AZ1, and then your disk will also be in AZ1.
I see. I see.
So from the disk perspective, it's definitely tied to the VM if you specify it that way. Um, for storage accounts, again, it depends on the application. Sometimes you think, I just want a storage account. It's going to be LRS because it's not really that important data. And then you think, well, is the actual latency to and from the storage account that important? It might be, in which case you can actually just deploy some VMs into different availability zones and just test to and from the storage and see which one
Mm,
has the lowest latency. And you kind
mm,
of find out where you need to be.
right.
The alternative would be look at something like zone redundant storage and actually, because that has a read and a write endpoint for each zone, because it's all doing the synchronous replication. So you get a much more standardized and predictable latency there. Because you know that you go to your local write point and you go through and it then gets replicated around.
I see.
So
So it's always
actually,
going to your local zone in that case, if you do
yes,
ZRS.
yes.
Oh,
So that way
that's
you
a key point.
actually get kind of a really good performance benefit. Yes, the storage subsystem has to replicate it, but you're not going from your VM in zone 3 to your storage account in zone 1 and back again. You kind of take a more optimal path. Works
Excellent.
especially well for for reads, sorry, because you're always reading from your local
From
point.
from the local point. That's
Exactly.
right.
So again, it
Yeah.
comes back to your application. What's it doing? It's always a tricky one when we're talking about any cloud migrations or anything like that, broadly speaking. What does your application actually do? How does it work? In sort of traditional platforms where you have a massive SAN, you get an HP 3 PAR and you pay a lot of money to have it there, and it
Right.
gives huge amounts of performance and things like that. You don't worry about what your application does. You just say it needs this amount of disk. It's generally speaking, you need an amount of storage, not an amount of performance.
Right.
But now we bill you if you need additional performance. And so it really drives the behavior of what does your application do? How does it work? And really kind of gets people to focus on that. And it's hard. It is
Right.
tricky to kind of start thinking in that way. But it's how you get the most out of the cloud, I think.
Excellent. I know we only have a few minutes here left, but I want to just touch upon ADLS Gen 2 because you did mention that earlier as another
Hmm.
option. And I'll be honest with you, I haven't used much of it. I don't know if you see that a lot with customers, but when should they be thinking about that specific option in Azure Storage?
Yeah. So Azure Data Lake Storage Generation 2, again, we love our acronyms at Microsoft. Um, that is designed really as a different interface into storage. So if you have blob storage, your main way of dealing with it is via HTTPS. It's got a REST API and making calls there. ADLS adds a more traditional hierarchical namespace over the storage account. So you can actually read and write to it, mount it via NFS, or read and write to it in that sort of more traditional file-based approach.
I see.
So it's very good at machine learning and analytics workloads, which kind of can operate in very much in that fashion.
Okay. And since you mentioned files, I'll just ask real quick. I mean, there's Azure Files, then there's Azure NFS. And then now ADLS, it seems like we have this plethora of options, right, for giving like a file-based interface into storage. Is there like a sort of process that customers have to go through to pick one or the other? It's all like based on like operating system limitations and constraints or whatnot.
Yeah, it's the file-based stuff is tricky. For just as a kind of a general rule of thumb, if you want random access, kind of traditional file share usage, Azure Files is the way to go. If you want large files, sequential access, NFS on Azure Blob would be the way to go. That's kind of a good,
I see.
that's a good start of hierarchy way of thinking about it. If you've got like, I've got some user file shares, that's always a good one, or profile shares, Azure Files 100%. If Azure Files doesn't, or you just want to choose a different option, then something like Azure NetApp File would be another fantastic choice. It's very, very good because NetApp Files, one of the good things about it, it only the only kind of throttling is on bandwidth, so not on IOPS. So if you have a huge number of very small files, then Azure Files has kind of IOPS limits associated with it, as opposed to NetApp Files, which doesn't. So you may find you get much better bang for your buck going for NetApp Files over Azure Files in specific scenarios.
That's very insightful. Thank you. This is
No
great,
problem.
Ben. Yeah, just I think all my doubts about storage accounts have been covered here today, for sure. I hope our listeners also got a lot of it out of it. Is there anything else you'd like to share with them before we wrap up here?
I think just storage is cool. I know it's one of those things. It fades into the background. It's kind of table stakes for everything. But if you think it's such a globally massively distributed system that backs some of the most mission critical and important applications that we run as Microsoft. I mean, yes, you want to do something on Xbox, well, that's backed by Azure Storage, and you want to do something else on a customer application, like a load of it is all backed by Azure Storage. Even your
Yeah,
podcast, the
yeah,
media files are hosted on Blob Storage.
that's correct.
So it's such a cool platform that fades into the background a bit too much sometimes. So yeah, I want more storage stands.
Well, thanks so much for sharing us, and especially giving us that process, right? What should we think about when creating storage accounts or using them? I think that's very insightful. So I certainly appreciate that. Well, thanks again for coming on and sharing this with our listeners, and we'll certainly look to getting you on in the future sometime when we have more to talk about storage.
Absolutely.